Can you all hear me?
Yes.
Okay, awesome. Hi, Jefferson. How is everybody?
Good. How are you? Good, Chili.
I'm doing well, thank you. Okay, let's get started. So tonight, I'm going to start with chapter 7 and then move on to chapter 8. But I'm going to skip parts of both because I don't want to have two chapters in one night, and it's going to be very hard on you otherwise, okay? So please pay attention because I'm skipping parts of either chapter. Okay, let's get started. Now, nature of industry. First of all, what is industry? What is industry? Okay. So market is synonymous with supply and demand, basically. Like, if mathematically, if you try to model the markets, you'll be literally talking about supply and demand. Industry, Jefferson, did you have an answer for industry? What is industry? I can see like 17 students on that screen. There's not one answer? Hi. Does that mean like you want to answer the question? Or are you just waving?
I was saying hi.
Okay, hi. So an industry is a group of firms that produce a similar product. Did everybody hear that?
Yes.
A group of firms that produce a similar product, like food industry. Like every firm in that industry is producing something related to food. Electronics industry. Everybody in the industry is producing something that's an electronic product. Okay. Okay. So nature of industry. Okay. Here are the learning objectives. Now, when we think about industry, one of the things we are going to be studying over and over again is like basically how competitive is the industry. There's a spectrum, right? There's the most competitive industry, which is perfect competition. And we are going to define that in chapter 8. And then there's the least competitive industry in which there's only one firm, which we call monopoly. Okay. We're going to study what are the benefits to competition. And then we are going to look at how monopoly affects all kinds of aspects of an industry. Okay. Now, what kind of impact does industry structure have on managerial decisions? Now, as a manager, right, what is the most important decision you have to make? What is your main job as a manager? In one word. That's very good, profit maximization. That's like two kind of. But in one word, it says optimization, right? In general, all your problems are almost optimization problems, okay? Like, you have constraints, right? You have cost constraints, and your objective is usually profit maximization, if not always, okay? Or should be. Now, the number of firms competing in an industry have implications for managerial decisions, because the number of firms in an industry and the size of the firms relative to the industry together determine if you face much or if any competition, okay? Some industries might have a lot of firms. They might have like 10,000 firms, but like the top 5 firms might dominate the industry. Like they might account for like 90% of sales, okay? So by itself, just the number of firms is not enough. Like you have to know the industry concentration too. And we are going to give like technical measures for that, okay? Now, as I said, like relative size of firms really matter. Another thing is like what barriers to entry exist, because in industries where there's free entry and exit, there are no barriers to entry and exit. You're going to face a lot of competition because anybody who wants a share of the profits in that industry is going to want to be in that industry. Industries like small farming, basically like somebody who sells at the farmers market is going to face a lot of competition. If there are any profits in that industry at all, there's going to be a lot of entry of firms. Now, another factor is like demand conditions, like, is your demand elastic or not? and how much demand does the industry as a whole have? How large is the industry basically? And I already mentioned ease of entry and exit. Now, industry concentration, that's the first thing we're going to study. Remember, I said not only does the number of firms matter, but more so industry concentration matters. You could have 10,000 firms, but 9,999 might account for only 1% of the sales. Okay, 99% of the sales might be just by one of the firms, 1 out of 10,000. Okay, we're going to look at like two measures of industry concentration. The first is the four firm concentration ratio. The second one is the Herfindahl-Hirschman index. Now, the four firm concentration ratio, it's almost like a tongue twister. It's very simple in that it takes the top 4 firms as far as sales are concerned. So these are the 4 firms that have the most sales, adds their sales together, and then divides it by the total sales in the industry. Okay, and the book gives an example, or the PowerPoints give an example. Let's assume there's an industry in which 4 firms have $10 of sales and 2 firms have $5 of sales each. So basically, the top 4 firms in this case have $40 worth of sales, and total sales in industry is $50. So 40 divided by 50 is basically 0.8. Okay, so the higher that number is, like close to 1, basically, like if it's 1, you have monopoly. Like the lower it is, the more competition there is. Okay. The next measure we are going to study is the Herfindahl-Hirschman index. It's a little more complicated. Does anybody know like what that symbol is? Like after the 10,000, or what that notation stands for? Summation, right? That's the Greek letter sigma, uppercase Greek letter sigma. So this basically says sum from the first firm to the end firm. Okay. However many firms are in an industry, like, if there are 100 firms in the industry, capital M will be 100. Okay. Next, you do the operation in front of the sum, which is basically that firm's sales compared to the total sales in the industry. So if the first firm has like 1% of the sales, right, this ratio will be 0.01. And then you square it, it'll be like 0.0001. Okay, it'll be 1 in 10,000 basically. Now, and then you do this for all the firms, and then add it up across firms, then multiply that ratio, that by 10,000. Okay, here's an example. Oh, the book does not give an example. Okay. Okay, let me give an example. Oh man, this is going to be hard, like, because that's computationally so intensive. Okay, now. Actually, you know what? Okay, so I'm just going to illustrate the computation. I'm not going to really sit down here like compute a Herfindahl-Hirschman index. Actually, you know what? Let me do it. Let me do it. Why not? Let's say there are 4 firms, each have 10 sales. Okay, so the sales for the first firm is 10. You know what? Let's make it even easier. Let's assume there are only 2 firms. They both have sales of 10. Okay. So in this case, the formula is going to be this. There's this 10,000, the first part, right? And then you have to sum from the first firm to the second firm, the sales, the relative sales of the firm relative to the industry, and square that. Okay? Now let's do this. So this part is, of course, easy. You multiply whatever you find by 10,000. Okay? Now the first part is going to be S1, which is 10. The total sales is 10 plus 10, 20. But then you have to square this. And then you have to do that for the second firm too. Okay? And then you have to add those 2 up and multiply it by 10,000. Now, what is the first part? That's 1/2. You square it, it becomes 1/4. And then the second part is also 1/4. So that's then summed up 2/4, which is 1/2. And then you multiply that by 10,000. You get 5,000. Okay? This is kind of a concentrated industry. Like, you want this number to be really small. Like, you don't want this number to be like, if there was one firm, let me ask you, what will this ratio be? Not ratio. What will this Herfindahl-Hirschman index be? What will the index be? If only one firm, monopoly. 10,000. Thank you. Very good. Because then in that case, you'll not even have the second part. It'll be like, this ratio will be 1. You square it, it's 1. You don't have to add anything else because there's no other firm. So you multiply 10,000 by 1, you get 10,000. So the highest this number can be is 10,000. Okay? And then from there, the more competition there is, the smaller it gets. Okay, now. It's not a Samsung, but still it's Microsoft, it's not too bad. Of course, that's a bad comparison, right? They're completely different firms. One is like producing hardware, the other is producing software. Different industry. Okay. Of course, Samsung, I think, probably writes some of its software, OS. I don't. Oh, they use Android. No, they don't. Yeah. Probably for them. Okay. Okay, we computed that already. Here are some numbers for industry concentration. Okay. Now, if you observe, apparel has a very low Herfindahl-Hirschman index. That industry has a lot of competition. Okay. So anything above 1,000 or 1,500 is kind of concentrated. Soap and cleaning compounds. Usually those companies are multi-billion-dollar companies. Okay. You're not going to be competing with the giants in the industry, chemical industries and stuff. Okay. So those industries are going to be concentrated. Motor vehicles, 1744. I mean, you're not going to compete with GM, Ford, and Tesla, and so forth, right? You need to compete with them, you need at least on the order of tens of billions of dollars, and you have to be much smarter than them at that even $10 billion to compete with them. Okay, I mean, it's not impossible, right? Tesla came from less than $1 billion company to almost $1 trillion company. So even the big guys get beat, but it's kind of, there's a huge capital barrier. Distilleries Anheuser-Busch, right? I'm not going to compete with them with even $100 million. You know what I'm saying? Those industries are very, your beer is made by a few companies. You could count them with your fingers, okay? Of course, there are probably 1 million companies that make beer, but most of the beers are made by 4 or 5 companies, okay? They dominate the entire industry. Snack foods, same way, I mean. Now, sometimes people say, oh, these industry measures don't actually show how much competition there is really in the industry. You might have 2 big firms or an oligopoly with a few firms, but they might still be competing a lot, okay? So there's that criticism, partially correct, Also, a lot of these firms face foreign competition. We live in a global world, right? So markets are really efficient. Now, and sometimes within those industries, there are different product classes. Yes, as a general rule, they might be large firms, but they might have a lot of products for which and some product classes, they might face a lot of competition. Okay, technology. Technology, of course, remember, what is the manager's problem? What's the manager's problem? What did we say? Optimization, right? Basically, profit maximization. Now, what is profit? What is the definition of profit? Does anybody remember from their micro undergraduate classes? What is the definition of profit? Profit is total revenue minus total cost, right? Technology, of course, remember, revenue is basically price times quantity. Of course, in this case, you have to realize price is a function. Basically, it is your demand curve, in a sense, your inverse demand curve. So the first part is a function of quantity, because price is a function of quantity. You're multiplying by quantity. And then the second part, your costs depend on quantity. But the functional form, how those costs rise, is going to be dictated by mainly technology. Okay? So if you want an advantage over your competition, technology becomes very crucial. Okay? You know, your process and production technologies are going to determine how profitable you are in an industry. Okay? Of course, there are other factors we are going to see in a few minutes, like things like economies of scale and so forth. Okay? Things like patents too. Like if you hold a patent in the United States, you're protected for like many, many years, like, you know, up to over, sometimes I think over 2 decades, a little over 2 decades. Now, if the firms in the industry have access to the same technology, you don't have any competitive advantage or comparative advantage against your competition. In that case, there's going to be a lot of competition. If everybody's using the same technology or has access to the same technology, you have no comparative advantage. The next guy is as good as you. Okay? In that case, you know, basically you're going to face a lot of competition. Now, here it says like industries with low demand and imply a few firms. That is not exactly true. Like, you know, like, I mean, like if you took farmers as an industry, right? And compare their demand relative to like certain industries like automotive, you know, that statement becomes not true, right? Because like, yes, there is low demand relative to the bigger industry in terms of sales, but how many farmers are there that sell in the farmers market? Probably in the tens of thousands, if not hundreds of thousands, right? Depending on how big you define the industry. So partially true, you know. Now, elasticity of demand is a very important factor. This is basically has to do with the slope of your demand curve. The more elastic your demand curve, let me actually show that. This is very important. So let me draw two demand curves. Like firm one, let's say, has this demand. And then the second firm, which firm has a more elastic demand? Huh? The second firm, right? The second firm. So let's say they both start at the same point. So both firms are charging $2 and they're selling 30 units of product. Because here's quantity, here's price, right? And all of a sudden, these firms decide to raise their prices, right? So let's say these firms raise their prices to like $2.60, right? So the firm that has the less elastic demand loses some of its sales. Their sales drop to 28. But the firm with the elastic demand, their sales drop to 20, right? So if your demand is elastic, your ability to control price is less. You know, if you increase price by even a little bit, you lose a lot of sales, okay? So industries in which firms face really elastic demands, such as like farmers market or like restaurant industry, there are huge implications for raising price. But if you are a monopoly in an industry, you have a lot more control over price. You could raise price a lot by losing very little sales. You know, like, I mean, the most extreme case will be like you are like De Beers, like you have a monopoly on diamonds. They used to have more of a monopoly. Now, like there's artificial diamonds. There's even like, they couldn't even tell which diamonds are which diamonds because like physically it's almost impossible. So they have to like sign their diamonds with like some laser or something, like, you know. So, but still, like, you know, if you're De Beers, you have much more control over price, okay? Worst case scenario, you're an oligopolistic industry, like, you know, whereas, you know, in an industry like you're like just a farmer, like you're a drop in the ocean, like, you know, like you raise your tomatoes and the next guy is right across from you, right? He has his stand. You sell the exact, if you sell the exact same tomatoes, you raise your price even by 5 cents, people are just going to walk over there. Okay, you lose all your sales for just 5 cents increase in a pound of tomatoes. Okay, now the Rothschild index is basically a measure that measures your elasticity relative to your industry, okay? Relative to your industry. Now the firm's elasticity is in the denominator, the industry's elasticity, total elasticity for the total product. The demand for the industry has ET elasticity. The firm's demand has EF elasticity. Now, remember, the more elastic your demand is relative to the industry, right? So this will be in absolute value large relative to this. They're both negative numbers, right? What is the highest elasticity can be in absolute value? What is perfectly elastic, right? What does that mean? What is the elasticity number for perfectly elastic? Horizontal, but what is the number for elasticity? It's negative infinity, right? So if the industry has a demand that is like just negatively sloped, but you as a firm have infinite, right? Elasticity. They're both negative. This is like -5. Yours is like negative infinity, right? What does the ratio become in limit? Zero. So for firms that are like really elastic relative to the industry, this goes towards zero. So you're at a complete disadvantage, like, in like price control. You raise your prices even a little bit in that industry, you're going to lose all your sales, okay? So the smaller this is, the more competition there is for that firm, okay? Like there's an example for the airline industry, and this ratio is 0.75, which kind of is still relatively large, right? Because the largest that can be is like you have the same elasticity, let's say. Of course, it could go the other way around too. So this is kind of still not zero, like, it's high, okay? Airlines, like the smallest firm in the airline industry, depending if you took like tiny carriers out, is still going to have some control over prices, like, it's still a concentrated industry. Actually, we can go back and look at the numbers for the 4-firm concentration ratio Rothschild index for airlines, and it's going to be a high number. Let me see, actually, just out of curiosity. I want to go back. Is airlines in there? Macro Hill, you just killed me. Of course, it's like one of their books. I'll put that there. That'll be nice, right? Good comparison. Okay. So look at here, like, like food industry. There's a lot of competition, because there are a lot of small firms. On the other hand, tobacco, like much more concentrated, right? Philip Morris, like companies, giant companies, right, dominate that industry. Textiles, relatively small. There could be a lot of like mom and pop, like, small textile firms in that industry. And there is, chemicals, hugely concentrated, right? Like you're like basically Koch brothers and stuff. Like, you have a lot more control. Rubber, like much more concentrated, like relative to other industries. Petroleum, like, you have to be giants, right, in that industry. Most firms are giants. Like those are all oligopolistic industries. A few firms dominate the entire industry. Okay. The lowest here is food, because there are a lot of small firms in that industry. Now, entry and exit are very important as far as your ability to compete or your comparative advantage goes. Like, if anybody can enter and exit your industry, right? Again, let me give the same example. If you're a farmer at the farmer's market, right, and you happen to be making profits, and the next guy hears about it, that year you made $100,000 selling produce at the farmer's market, right? How difficult is it for them to set up a stand? Relatively, it's very easy, right? You don't need much capital to enter that industry. So for that reason, in the long run, you can never make profits in that industry, okay? It's kind of course, when we say in the long run, you make zero profits, that covers your opportunity cost. Remember, here profits are economic profits. They're not accounting profits. In that industry, you cover your salary and everything. When you say zero profits, you still get, it's not like you didn't get paid anything. No, you got paid as much as if you had worked for somebody else doing the same job. Okay. Now, the first thing that could affect entry and exit in an industry is capital requirements. Some industries have giant capital requirements, like the automotive industry. I mean, an automotive plant might be is on the order of billions of dollars. You're not going to say, oh, I'm going to become Tesla, like, tomorrow, right? You have to raise big capital, okay? That's why, like, there are few firms that are in that industry. You could count them with your fingers, okay? The second thing is patents. You might be a very small firm in a new industry, but you might have a patent, right? That could potentially make you into a monopoly in that industry, depending on how important the patent is. Okay. Of course, over time, the demand for your product kind of becomes more elastic because people find alternatives and stuff to your product. Okay. Now, the last one is economies of scale. Economies of scale is very important, actually. I think in the United States, especially, most industries use economies of scale to reduce average costs. Okay. Usually these are industries that have huge capital requirements because economies of scale does not apply to the farmer's market farmer. It applies to companies like Tesla. It applies to companies like GM and so forth. If you compare Ferrari to GM, right? Ferrari is a very small company, right? Why does it sell a Ferrari for like in the hundreds of thousands range when GM sells it in tens of thousands range? The biggest reason is basically economies of scale. If you make like 10,000 cars a year, right? And you still have to have a plant that makes those cars that cost billions of dollars, right? Your average costs are going to be very high. Whereas if you are GM, you're making cars in the millions, your average costs are going to be much lower. Okay. So that gives you an advantage over your competition. That's why GM is I don't know, right now, like $60 billion company. Whereas Ferrari, I don't know. I mean, I don't know, 510. I'll be surprised if they're that much. Probably 510, something like that. Okay. Now, price behavior, how firms make pricing decisions, or how they compete, or how do they collaborate? What is their strategy as far as advertising goes? Remember, technology gives you a cost advantage, and a lot of times technology is not a factor. You cannot buy it in a market. There's a lot of risk you take when you invest in technology. Most companies in high tech do not reap the benefits of their products, even if they invent a product. I could give you 1,000 examples. A lot of industries, if you could end up spending $1 billion on product development, and maybe 3% of the time you reap the benefits. Okay, so that's why actually in certain industries innovation is really stifled. Nobody wants to really do it. Companies like Google, companies like Microsoft, companies like Intel, they're not actually competitive at all. Their technology and innovation, despite what they advertise, is very moot. Okay, so now learner index is a measure of your basically competitiveness. Remember, price minus marginal cost divided by price, right? That's how the index is defined. Now, for a competitive firm, price equals marginal cost, right? A competitive firm, we are going to see in the next chapter, charges marginal cost. This difference in the numerator for a competitive firm, perfectly competitive firm. I should say perfectly competitive because there's monopolistic competition too. So for a perfectly competitive firm, the numerator is 0. You divide it by any price, you get 0. So the most competitive industry has a learner index of 0. Okay. Now, if your marginal costs were basically 0, this will be 1. Okay. That's indicating much less competition. Now, then you have the markup factor, which is, you can rewrite this rearrange it as the second equation, and the first component on the right-hand side, we call it the markup factor. Now, the markup factor, basically, remember the learner index for the most competitive industry is what? It is 0, right? So what is the markup factor for the most competitive industry? 1. Okay, 1. That's for perfect competition. For monopoly, it is less. Now, here's an example. The firms in the airline industry are charging $200 marginal cost, has $200 of marginal cost, and they're charging $300 for price. So you compute the learner index is 1/3, and the markup index is 1.5. Now, this is relatively close to 0, which tells you there isn't much competition. Okay. So the closer this to zero, the less competition there is. Like tobacco, there's not much competition in that industry. Chemicals, not much competition. And this also, remember, like we looked at the concentration ratios, Herfindahl-Hirschman index for these industries, and you can see the same result. It's just a different measure of competition. This is just using price and marginal cost. It's like different ways of measuring competitiveness, basically. You know, and remember, for the competitive industry, what was the Lerner index? 0. Was it? Hold on, let me check. Yes, it is 0 because price is equal to marginal cost. The numerator is 0. That's perfect competition. You know, for perfect competition, the most competition gives you 0 Lerner index. So let's look at like Lerner indices that are close to 0. Food, yes, like I said, a lot of competition in that industry. And we saw the same from the concentration ratios and Herfindahl-Hirschman indices. Okay, so tobacco, not competitive at all. Like, you know, like you have Philip Morris's and stuff in that industry. Like, you know, most of the cigarettes people smoke are made by, the brands are made, they're owned by the same company. Okay. Okay. Now, sometimes firms like collaborate or internalize the production processes to get a price advantage or make more profits. Okay, here are some examples. Integration, right? You know, like basically you buy resources from the same source. That's one way to do it. The second one is a merger, like, you know, firms get together as one firm. Okay, you know, like there are some mergers that went through antitrust, like AT&T and so forth. Like, you know, some famous ones recently, like what is like T-Mobile merged with Sprint. Yes, that's recent one. Okay, when you merge, usually the motivation is to reduce costs for a given level of sales. Okay, so your base, it increases your profits. Of course, it's not good for the customer because you become less competitive. Remember, the industry becomes more concentrated or less competitive after a merger. If a firm tells you, oh, this is in your benefit, you know, I mean, are they telling you the truth? You can answer that for yourselves. Now, you know, the more market power the firm has, meaning like the less elastic a demand curve it faces, the more the less the implications for raising prices for it are. Okay, if there's only one firm, they can always say my way or the highway. Of course, sometimes size really matters because, you know, a company like Tesla, right, worth like right now in market cap, I don't know, like $700 billion. You know, that company has like insane access to capital, right? 10 years ago when Tesla was like $1 billion or sub $1 billion company, you know, it almost went bankrupt actually. Elon Musk put all his leftover money from PayPal's sale proceeds and saved the company. You know, who would have known like 10 years later it's going to be a giant, like dominating all the other top 3 or former top 3, I should say. Okay, vertical integration is like, you know, when you put different stages of production together. Horizontal integration is like, you know, when you pick up different products and put them under a single firm. Now, conglomerate mergers is, you know, like you take 2 or more different product lines into a single firm. Okay. Now, you know, like for example, like if Coca-Cola joined, it is like water products with their like soda products, right? By buying some company, like, you know, that'll be like a conglomerate merger. Okay, research and development. R&D. Now, what are the R&D budgets of certain firms? You know, pharmaceuticals, 19.7, Ford, 4.1. It's actually like for pharmaceuticals, and this is even, I think, exception, like, you know, for most firms, it's not much. Okay, so they don't have much product development. That's why, what is the market cap of Ford? Can somebody Google that? What's the market cap of Ford? How about like 30 billion? If that. wow, it went up because they come up with a few electric product lines. It used to be like sub 30 recently. So 47, you know, like that's why Tesla is a $700 billion company and they're like a $47 billion company, even when they're trying hard. Like, you know, because why? Because look at the budget, 4.1%. Still a lot actually, but somehow these old companies, they're not efficient. A lot of bureaucracy within the firm. Now, advertisement, if you look at the advertising budget, you know, like cosmetic soap, they're at the top, you know, pharmaceuticals, you know, it says like 4.9. It's maybe because the firm is so big and profitable. But if you look at like on TV recently, most of the commercials you see are for like pharmaceuticals, right? Ton of, and they're all long, like, you know, they're like, sometimes they span over a minute. Okay, very interesting. So things might be changing, like, you know, these numbers are dynamic, like, you know, you can't just take them as given. This is like a snapshot of the markets at a point in time. This is if this is 2017, you got to be careful, like, you know, the numbers for 2021 might be very different. I wouldn't be surprised if the advertising percentage of sales for pharmaceuticals is really going up. Okay, I'm going to finish chapter 7 here, and then I'm going to move on to chapter 8. Any questions so far? Okay, so in chapter 8, we start to study in this. Go ahead, sorry, question? Jefferson, did you have a question? No, okay. So here we really start studying industry structures. Like there are 4 main industry structures. The most competitive industry structure is perfect competition. Then there's monopolistic competition. Then there's oligopoly. Then there's monopoly. Monopoly is the least competitive market structure. Monopoly is basically one firm for the entire industry. Now here are learning objectives. Now perfect competition. For an industry to be perfectly competitive, it has to satisfy all these conditions, okay? Now, the first thing is, in a perfectly competitive industry, the firm, not only do you need many firms, the firms have to be really small relative to the industry, okay? You might have like 10,000 firms, but if almost all the industry is like kind of dominated by one firm, totally not perfectly competitive, okay? You have to look at the relative sizes. All firms in the industry have to be very small relative to the industry. It's like we're talking about like things like farmers markets and so forth, okay? You know, like gas stations, are they perfectly competitive? No, okay? Gas stations are more like monopolistically competitive, you know, like they're all different, like, you know, like they have like carry different products, you know, like they change themselves a little bit to attract customers, like they have their niches. So the second property is the firms in this industry produce a homogeneous product. Your product is the same as everybody else's. You know, like if I sell tomatoes, my tomatoes are as good as the guy right across from me, right? And we are both very small firms relative to the industry, right? I have no control over prices. But if my product was better, I was selling like better tomatoes than that person, I could charge more. In that case, it'll be monopolistic competition. You know, that's what separates monopolistic competition from perfect competition. In monopolistic competition, you have a differentiated product. Like restaurants are monopolistically competitive. Why? Yes, they are competitive. There are a lot of firms that are all small relative to the industry, but their products are not the same. Some restaurants have better food. Some restaurants have, you know, better hygiene. You know, they have better service and so forth. You know, that for that, you could charge a little more compared to your competition. Now, buyers and sellers have perfect information. Nobody has an information advantage over their competition. You know, if you did, that'll be a barrier to entry, or that'll give you like comparative advantage over your competition. You know, like at the farmer's market, right? There's nothing that you know to have an advantage over the next guy that they don't. Okay, it's simple, like, you know, there isn't much to like being in that industry. No transaction costs. If there are transaction costs, you know, that actually makes the industry not competitive. Okay. You know, like search basically, like for example, like, you know, like if it costs you a lot to search, right? the market, like, like at the farmer's market, for example, transaction costs are zero. Like looking at this farmer versus this farmer, right? Like, so there's no search, like, you can look at the prices immediately. Like, it's not like you are having a hard time finding the best price. You know what I'm saying? Like, in industries in which like you don't have access to like the best price information, there are transaction costs, there are search costs, and prices are going to be different in that industry. Okay. If the buyers don't have perfect information, they don't make perfect decisions. You are going to have firms that charge different prices. There's not going to be one price in that industry. Okay. Like there might be a gas station down the road, but it's like so obscure in a neighborhood, right? But they charge like 5 cents less than everybody else, right? But the reason they are like doing that is, and I don't have access to it because I never knew there was a gas station there. Okay, there's transaction costs. Free entry and exit from the market, like, basically there's zero capital to enter and exit this industry. Anybody in that industry can leave anytime they want. They can enter anytime they want. Okay. This is important. Firms earn zero economic profits. Remember, that covers opportunity costs. Firms in this industry still make accounting or cash money, but just enough to cover their opportunity cost. Okay. Like at the end of the year, if you counted the money they make in profits, it's basically only accounting profit. There is no, basically your economic profit is zero. You only cover your opportunity cost. Now, if you look at the industry supply and demand and compare it to the firm's supply and demand, the industry supply and demand looks like any other industry. But if you look at the firm's demand, it is perfectly elastic, meaning this firm has no control over prices. It's a drop in the ocean. This firm cannot even raise. Okay, let me ask you this. This is like a little deceptive, like, the real demand curve is not horizontal, actually. It is, let's see. It's an L. Okay, it's an L. Meaning, if you charge any price above this price, right, you'll be actually on the y-axis above that price. And that'll automatically give you zero sales. Okay, no firm can even charge a penny over the market price dictated by supply and demand in the industry. Okay, farmers' market price for tomatoes is determined by all the farmers together. Okay, so the individual farmer has no control over that price. If the market dictates price is $2 a pound, they cannot even increase it by a penny. If they increase it by a penny, they lose all their sales. Interestingly, although gas stations are not perfectly competitive, their prices are very competitive, right? Gas stations are monopolistically competitive. But since there are many firms, and since kind of there's like almost perfect information, right? It's very hard for gas stations that are right next to each other charge a higher price than the one next door, right? Sometimes it happens because the product is a little different. You might have like shale gas versus like marathon gas, and people might think like shale gas is better, and probably is. So in that case, you could charge maybe 5 cents more over like 250, okay, or 20 cents more, and still not lose all your customers, okay? But like most gas stations, if you have like Weigel's here and Marathon right across the road, prices are going to be exactly the same, okay? Because there are no transaction costs. You can look at the prices. And if you think gas is the same, it's a homogeneous product, where do you go? Wherever it's cheaper. If they raise the price by a penny, they'll lose all customers, okay, in theory. Sometimes, like, it might be like access is easy, the way the terms are and stuff. And sometimes they differentiate themselves by selling like cheap, like soda or something. So they might command a little bit of price, but that also eats into their profits. It might be more like an advertising gimmick, and they might not be able to do that long term. Okay, now when we talk about firms making decisions, the time horizon matters. Short run decisions are going to be different from long run decisions, okay? Remember, we said for the competitive firm, there is free entry and exit. That is only true in the long run. Only true in the long run. In the short run, a competitive firm can earn positive economic profits. Now, what happens if a firm earns positive economic profit? If a firm earns positive economic profit, new firms enter the industry. The word gets around. Since there is free entry and exit, new firms enter the industry. Now, let me ask you, what happens to supply if new firms enter the industry? Increases. What happens to the equilibrium price if supply increases? Decreases. Decreases. You know, if there are more gas stations in a town, gas is going to become cheaper. Okay, of course, gas stations, remember, are not perfectly competitive. You know, but at the farmers market, like, you know, if more people set up shop, you know, because like some people are making positive profits, those profits are going to be in the long run eaten to zero. Okay, to zero economic profit. So in the short run, if you want to maximize profits, let's look at this graphically. The best way to look at this is graphically. Okay. You know, there are two ways to look at the graph. Now, remember, here's the bigger question. How does any firm maximize profits? What's the profit maximization condition for any firm? Exactly. Because remember, what is the firm trying to do? It is trying to maximize basically net benefit, right? Total revenue is your total benefit. Total cost is your total cost, basically. The difference is net benefit, right? And remember, what did we learn? How do you maximize your net benefit? By equating marginal benefit to marginal cost. In this case, marginal benefit is marginal revenue, and marginal cost is marginal cost same. You know, so profits are maximized when marginal revenue equals marginal cost. That is true for any firm, not just competitive firms. Okay, not for competitive firms. Now, when the slope of the total revenue, which is marginal revenue, is equal to the slope of the cost function, that is the profit maximizing quantity. Here, that occurs at, let me see what number is showing, like my screen is, that happens at Q star. What is true at Q star? The tangent to the total cost function, which is marginal cost, is the same as the slope of the total revenue function, which is a constant because total revenue is a linear function of quantity, okay, in positively sloped. So the slope of the first function is constant. The second function slope changes. This is a nonlinear function, the cost function. So when the two are equal, meaning these two lines are parallel, you have marginal revenue equals marginal cost. At that quantity, you maximize profit, okay? So the profit maximize, that's one way to look at it. Then there's another graph, which I don't know if yes, the book covers it, okay. For a second, I thought it's not covering it. So this is a different way of looking at the same thing, right? So of course, for the competitive firm, remember, marginal revenue equals marginal cost is a profit maximization condition for any industry, any industry. It's true for the competitive industry, perfectly competitive, monopolistically competitive, oligopoly, and monopoly. But the competitive firm, remember, is a special firm. What is true for the competitive firm? Price equals marginal revenue. Price equals marginal revenue. Why? Because for the competitive firm, price is constant. The demand curve is horizontal. You know, if the price you charge, right, is constant for any quantity, what is your marginal revenue? Marginal revenue is the extra revenue you make by selling one more unit of the good, right? You know, in the case of the competitive firm, that's just equal to price because every time you make one more sale, you just get to charge the price. Your price does not change. So for a competitive firm, marginal revenue, price, demand, they're all the same thing. Okay? Now, marginal revenue equals marginal cost. Look at where the marginal cost function cuts the marginal revenue in this case, which is basically price. It cuts it at this point, okay, this point. You go find your quantity. So what is the firm's problem? Finding the quantity that maximizes profit. You know, the only thing they control in this case is quantity. The entire profit function depends on quantity. The only thing they have to do is find the quantity at which the profit maximization condition is satisfied. Remember, what was the profit maximization condition for any firm? It's marginal revenue equals marginal cost. But the competitive firm is not any firm. it is special. Unlike the other three industries, for the competitive firm, the demand curve is horizontal, meaning price equals marginal revenue. So in the case of the competitive firm, you could replace marginal revenue with price. So for the competitive firm, what is the profit maximization condition? And only for the competitive firm, price equals marginal cost. Price equals marginal cost. In this case, where is price equal to marginal cost? It's where the two intersect. Here is price at P equilibrium, and then here's marginal cost. Where does it cut it? At this point. Which quantity does that correspond to? Q star. So what is Q star? The profit maximizing quantity for the competitive firm. Okay, what is the condition that is satisfied at that point? Is that a question? Jefferson, did you have a question? Okay. So, you know, at this point, is that a question? Okay. So, at this point, we have profit maximizing quantity where price equals marginal cost. Okay. Now, the next question is how much profit is the competitive firm making? It is making profit equal to this rectangle. Why? Because price minus average total cost, right? Price times quantity is total revenue. So the larger triangle is total revenue. If you multiply average total cost by quantity, what do you get by definition? Total cost. What is total revenue minus total cost? Profit. So the bigger rectangle minus the smaller rectangle, the bigger rectangle is total revenue. Why? Because it's price times quantity, by definition. What is the smaller rectangle? The one below the blue? That is average total cost times quantity, right? Because the area of a rectangle is height times base, right? So total revenue is the bigger rectangle. The smaller, when I say smaller, the bottom one, like not the one in that's the difference. It's total cost. You take total revenue, subtract total cost. What do you end up with? The difference is profits. Profits. So this rectangle is basically profits for the competitive firm. Okay. Now, if you look at it, those profits are positive. Positive. That can only happen in the short run. A competitive firm in the long run, that rectangle size will be 0. Okay. In the long run, that price will fall down to the point where it cuts marginal cost at the lowest point of average total cost. Okay. The long run equilibrium occurs at this point. So price is equal to marginal cost and it's equal to average total cost. Price minus average total cost becomes 0. You multiply it by the profit maximizing long run quantity, which is occurring here, you end up with 0. Okay, so long run profits are 0. This industry will have entry. Why? Because there are positive profits that will attract entrance. Okay, so the profit, like I just said, the profit maximization condition for a competitive firm is price equals marginal cost. Never forget that, okay? That is different from the other industries in that only for the competitive firm, marginal revenue equals price. That's not true for any other industry. Why is that true? It is because the demand curve of the competitive firm is perfectly elastic. Price, marginal revenue, demand, they're all the same thing. Now, here is an example. Your cost function is 5 plus Q squared. And if the firm is selling its product in a perfectly competitive industry at a price of 20, right? What quantity is it going to sell? Now, the first thing you have to do is like equate your marginal cost to your price, right? Because that's the profit maximization condition. Now, if you look at this cost function, you don't have to know calculus, but you know, the book will give you the form of the marginal cost function, the functional form. If you take the derivative of this with respect to Q, you end up with 2Q and 5 disappears, right? So 2Q has to equal to 20, which is price, right? So Q is equal to what? 10. If Q is equal to 10, what are your costs? There are two ways to go after that. You could compute average total cost, use the logic of the second graph, or you could plug it back into your cost function. That'll give you total cost. then you can multiply the price and the quantity to get your total revenue and take the difference. Now, what is my price? 20. What quantity is my profit maximizing quantity? 10. So what is my total revenue? 200. What is my total cost? 100, which is 10 square plus 5, 105. If I subtract that from 200, what do I end up with? $95 profit. Can this be the long run? No way. Okay. You know, in the long run, you will have to find the minimum point for the average total cost function, right? You can compute average total cost. And, you know, if you knew calculus, you could take its derivative and equate it to 0, check the second order condition to see if it is satisfied. Of course, in this case, it'll be satisfied. So, but that's like going a little over the level of this class. Okay. Now, the opposite is true too. Sometimes in the short run, firms make losses. When they make profits in the short run, new firms enter to the point where their profits go to 0 in the long run. When they are making a loss, which is the case here, why? Because the profit at the profit maximizing quantity, when price equals marginal total cost at Q star, average total cost is above price. Your total cost is more than your total revenue. You're making a loss. What's going to happen to this industry since it's perfectly competitive and exit is free? People are just going to leave, okay? Until profits go to 0 again, where price is equal to minimum average total cost in the long run, okay? So if there are profits, they attract entry. If there are losses, they convince firms or incentivize firms to leave the industry until only in the long run you have price equals average total cost, 0 profit, 0 economic profit, okay? Now, in the short run, there's a shutdown condition. You should remember, like sunk cost and stuff, your total fixed costs in the short run are irrelevant to your decision making. They're only relevant in the long run when every cost is variable, basically. There's no such thing as fixed costs in the long run. Okay? As long as you cover your average variable cost, not your total cost, you should operate as in the short run. Okay? If price is greater than average variable cost at the profit maximizing price and quantity, what should you do? You should actually keep operating. Okay? You know, because as long as you can cover your variable costs, you're profitable in that sense. Okay? In the long run, of course, that's not enough. You have to cover all your costs. What will happen? You know, most whatever you have will depreciate, right? And if you can't recover those, you can't replace them. So in the long run, you'll be out of business anyways, because you're making a loss in this case if you cover all your costs. You're unable to cover your fixed costs. Okay. So the shutdown condition is basically if price is less than average variable cost. If you can't even cover your average variable cost, you're better off shutting down and not at least making a loss. Okay, absolute loss. So if price is greater than average variable cost, continue. If price is less than average variable cost, shut down in the short run. In the long run, you have to cover your average total cost. Okay, at least cover it. Like, you know, 0 profits are okay. You can continue to operate. And in fact, in the long run, you'll be forced to in the competitive industry because of free entry and exit. Okay. So a competitive firm can eat some of its losses in the short run. So that's why, like, the short run supply curve for a competitive firm is the section of marginal cost above its average variable cost, because it's partially profitable as long as it can cover its average variable cost. Okay. Of course, if you want to get the market supply for the short run, you just add the individual firms' supply curves horizontally. For at each price, you add up 1 to. So, for example, like, you know, if there are, like, let's say 500 firms, you know, each produce one quantity at $12, 500 of them will produce 500. Okay. So that's called horizontal summation. Now, entry and exit, long run decisions, like, you know, if there are positive profits, enter, supply expense to the point where those profits go away in the long run. If there are losses, firms exit, supply contracts in the market to the left, prices go up until you have zero profits. Okay. And remember, supply and demand determine the location of your individual demand. You know, for example, when there is exit from the industry, your demand actually shifts up. When there is entry, your demand shifts down. Okay. Now, long-run competitive equilibrium, like I said, occurs at the minimum point of the average total cost curve when price equals marginal cost. It's literally this point, which is Q star. At that point, since price equals average total cost, your profits are by definition zero. Yep, we just said that. Monopoly. Now, monopoly is the other extreme. A monopoly is one firm owning the entire industry. Okay. You know, are there any monopolies? You know, sometimes they're like created almost by law, like, you know, like TVA. In Tennessee, you know, I'm not sure if there are companies that, small companies that produce solar power. There's probably a lot of regulation on those kind of firms. You know, almost all the power in Tennessee is under the control of TVA. So it's almost like a legal monopoly. Okay. Now, monopoly is one firm and it has a lot of control over prices. Any industry in which there's a monopoly, you know, this firm is going to have a control over price. Now, why is TVA then created if it has control over prices? Will it abuse its market power? Probably not. The reason they created TVA is there are huge capital requirements for producing power. You have to have power plants. They're very expensive. If you have two firms, you know, they'll operate at a lower scale. They won't benefit from economies of scale, and they'll have to charge a much higher price. Okay. And given the technology of power production has been established for the last kind of many years, decades, some of it over 100 years, kind of, you know, there's no benefit there either. Like, it's not like you're generating power with new technologies. Now, solar changes the balance. It's a clean product. You know, like there might be a benefit to introducing competition against TVA, okay, or forcing TVA to accept power from people who have solar at home, like, you know, sell it back to TVA. Okay, of course, that's going to affect TVA's scale. You know what I'm saying? If they cut their scale, they won't have as much economies of scale. If everybody did that, you know, it'll be kind of like you have to be careful. Like, you know, you might have to have like a different arrangement. So, but solar is very clean, so there are a lot of benefits to doing that. Now, of course, does monopoly have unlimited power? Not really, because their demand curve is not vertical, right? It's not like people are addicted to their product. Now, with power, today you have alternatives because technology introduced things like hydro, things like solar, you know, but how many people really like use or benefit from those technologies? You know, that's where like good regulation comes in, you know, but, you know, if the regulators are the same people who institute the legal monopoly to begin with, it's like, I mean, how do you solve the problem? Now, monopolist demand is negatively sloped. Unlike the competitive firm, this is just like the market demand for the competitive industry, okay? Remember, you have to make a distinction. For the competitive industry, the market demand is negatively sloped, just like the monopoly. But the individual firms, demand is horizontal for the competitive industry. You have to be careful, okay? Industry demand is always inversely sloped, or negatively sloped, I should say. But the competitive firms' demand for the firm is perfectly elastic, it's horizontal. Since monopoly is one firm, there is no distinction between industry and the firm. The market demand is the same as the firm's demand, which is negatively sloped. What does that mean? If the monopoly raises prices, it'll lose customers or it'll lose sales. Now, there is economies of scale. One of the reasons we have monopolies is economies of scale. Remember, I gave the TVA example. Those industries are called natural monopolies, like power generation, okay? And then there's economies of scope. Now, that happens when like you produce multiple products within the same firm and there are benefits to it, like, or like knowledge of one product benefits the production of the other product and sort of makes it kind of more profitable to have one firm operate at a with either multiple products or a higher scale. So in those cases, these are all arguments for monopoly. Now, sometimes you have cost complementarity. Like kind of the cost functions or the marginal cost functions of one product are related to the other. So you could reduce cost by producing both products in-house. And then the last one is patents. Like, patents give firms an advantage and a barrier to entry. And firms who own patents potentially could have monopolies. Okay. But of course, those monopolies will fade in the long term. Why? Because the patent will expire. Even if it doesn't expire, there'll be products that will compete with it. Remember, monopolies are usually in big industries. There's a lot of profit to be made. Everybody wants to be a share of that big pie, right? So there's huge incentive to innovate against the monopoly. Now, monopolies sometimes behave badly. Like they go against antitrust. What do? They buy your patents. Like let's say I have a patent on one of my inventions. Google can come and say, hey, Agir, here's $20 million. It's mine now. And I'll probably jump up and down, right? I'll be like, oh man, I made $20 million. Of course, Google can turn around, keep it in his pocket so that it stifles innovation, or it could turn it into a product. But even remember, Google is not like immune from, like, invention and innovation are different things. Innovation is much harder. There are so many products Google came up with that didn't turn into innovations. And some of those products, other firms were able to convert it into innovation, but Google failed at it. So it licenses it like to other firms. It might be because, I don't know, like that firm is more dynamic in some ways in innovation than Google. Okay, now elasticity of demand. Now the elasticity of demand, remember, for an inversely sloped curve is, like not perfectly elastic, but not perfectly inelastic either. Okay, it's between 0 and negative infinity and strictly excluding those two extremes. Okay, so which implies the marginal revenue curve for this firm, if it's a linear demand, will be twice as steep. Okay, so when you apply the marginal revenue equals marginal cost, right, for these firms, the price they will charge will be determined on the demand curve, but the profit maximizing quantity will be determined between marginal cost and marginal revenue. Okay, so if you look at that graphically, it looks like this, their profit maximization problem. Let me see if the book covered it. If not, I'll just throw it. Yeah, they did. So how does the monopoly maximize profit? What is the profit maximization condition for monopoly? It's the same as any other firm, right? Marginal revenue equals marginal cost. Of course, it's different from the competitive firm in the sense that for the competitive firm, it happens that marginal revenue equals price. For monopoly, that's no longer the case. Price is above marginal revenue because price is the demand curve, inverse demand curve, whereas marginal revenue is twice as steep. Okay, it's at any quantity, it's below it. So the first thing it does is it looks at this profit maximization condition, right? Which is marginal revenue equals marginal cost. Graphically, that occurs when the marginal revenue line or function crosses the marginal cost curve. This is at this point. Okay, that gives you your profit maximizing quantity. So QM is the profit maximizing output. Now, once you have to produce that output to make maximum profit, that automatically tells you what price you need to charge. Because for a given quantity, the price you're going to charge is going to be on your demand curve. So you go all the way up to your demand curve. Your demand curve tells you charge the PM as your profit maximizing price. Now remember, the next thing you have to do is find your average total cost at the profit maximizing quantity, right? What is your average total cost at the profit maximizing quantity? It is at this point. The difference is your profit. Like the difference between the larger rectangle, which is your total revenue, and the smaller rectangle. When I say smaller, it's still larger than profit. The lower rectangle, I should say. This one is your total cost. If you take the difference between total revenue and total cost, you end up with profits. So this blue rectangle is your profit. Now, this monopoly is making positive profits. It can make positive profits in the short run. It can even make positive profits in the long run. Why? Because there's no competition. You know what I'm saying? I mean, there are a lot of people outside dreaming about like becoming competition, but that requires a lot of work. Like super, like, you know, amazing companies like Tesla have been able to do stuff like that. You know, they've overtaken an entire industry. Almost. There's an example here. You know, you can look at that your free time. The exact same logic applies. Now, here's one thing I need to mention because this will be hard for you to see. Remember, never forget this. For a monopoly, marginal revenue is twice as steep as demand. For a monopoly, marginal revenue is twice as steep as demand. What does that mean? Your demand is your inverse demand curve, which is given by this function. How do you make it twice as steep? Here is its slope, right? To make it twice as steep, you make that 2 into a 4. So what is your marginal revenue function? Marginal revenue equals 100 minus 4Q. Okay? That's your marginal revenue, 100 minus 4Q, because that's twice as steep. Why? Because it has twice the slope. Okay? So your marginal revenue, here's your cost function, right? And this is a linear cost function, miraculously. You know, if you look at its marginal cost, it's just going to be 2. Okay? So 2 equals 100 minus 4Q, right? So in that case, 98 equals 4Q. Your Q is 24.5. Okay? And then you can plug that back into demand to find your profit maximizing price, right? You can multiply that price by quantity to get your total revenue and plug the profit maximizing quantity back into the cost function to get total cost. Take the difference. That's your profit. Profit maximizing profit. Okay? And this just requires like exercising, you know. I mean, now, you know, there's that point that monopolist does not have a supply curve and so forth. It's just, we're going to skip that part. You can learn that on your own. Sometimes monopolies have multi-plants. They have 2 plants, and they have to make decisions. What is the profit maximizing output for each plant? Okay. Now, your marginal revenue comes from demand, right? The demand is the same for both plants. They're both facing the same demand. So you compute your marginal revenue from your demand, which is just one demand for the monopoly. It's market demand. And then you equate that to the marginal cost for each plant. The 2 plants have different marginal costs. Why? Because they probably have different technology, different scale, and so forth. Okay? You know, which implies like your marginal cost of production have to be the same between the 2 plants at the profit maximizing quantities for each. So individually, you can solve from the once you find your marginal revenue by taking your demand to be twice as steep to get the marginal revenue. Then you take your marginal cost from the first cost function. Then you compute your marginal cost from the second cost function. Then you create your marginal revenue to each to find the quantity in each. Then you can add those quantities to get your total quantity, or you go back actually, if you want to compute your total profit, you compute the costs in the first by plugging in your profit maximizing quantity from the first into the cost function for the first. Then your profit maximizing quantity from the second one into the cost function. Then you can add up those 2 cost functions, right? And price is common, right? For both, we just solved it. You can take the 2 quantities, add them up, plug it back into the total, the demand function to get your price. Multiply that total quantity by price to get total revenue. Take the difference, that's your profit. It's very involved, but I believe the book gives an example. Is it? Does it? No, it doesn't. It's too involved. No, okay. Now, a monopolist obviously have barriers to entry. If there were no barriers to entry, there'll be other firms in the industry. Quite often, those barriers are patents. Those barriers are like, you know, natural barriers such as economies of scale. You know, like, like for example, like if you, of course, Walmart is not a monopoly. Walmart is an oligopoly. Okay, like it's a few big firms dominating an industry. Of course, but it's closer to a monopoly than like smaller firms. So you can't even become Walmart, right? If you don't have tens of billions of dollars. Like Aldi probably is worth, I don't know, $50 billion or something, right? It can compete with Walmart some in certain product categories, right? Food and so forth. It's very hard, like those capital barriers, I mean, are like big entry barriers, like, most firms cannot overcome them. And at the end of the day, let's say I'm competing with them, right? Like, I might still like lose. You know what I'm saying? It's like a big fight. Okay, now in the long run, monopoly in certain cases might earn zero profit, but it need not. If it was earning zero profit, this will be the situation. Most monopolies earn positive profits in the long run. Now, monopoly actually is not good for society. Why? Because monopoly causes deadweight loss. Like a monopoly, by charging a higher price than the average total cost or the minimum average total cost, or charging a price greater than marginal cost, those are two different versions of efficiency, allocative and productive efficiency. So violates both conditions. So a monopoly, in a sense, produces less than if the entire industry was competitive. Of course, you got to ask yourself the question: if you have a complicated product, right? How can it be developed by competitive firms? It depends on the product. Certain industries can be very competitive. Like small pharma is very competitive, and they have like amazingly technologically advanced products. But for most industries, that's hard to do. But as technology improves and product development becomes cheaper, that might actually happen. The future might be different. Now, the third industry structure we are going to study is called monopolistic competition. The only difference from perfect competition is the monopolistically competitive industry produces a differentiated product, not a homogeneous product. Product is different across different firms. There are a lot of small firms. None of them dominate the industry. There's free entry and exit. Sorry, there's a little bit barrier to entry in the sense that, you have a differentiated product. Okay, you have a little slight advantage over your competition. Like, the best example for monopolistic competition, the best example is like small mom and pop restaurants, or gas stations. Okay, not every gas station is the same, even when they are like, not even two marathons are the same. Not even two Weigels are the same, right? Because they might carry like different snacks or, like certain things. Access might be easy. Location is different. They might have little advantage over others. So a differentiated product is a product that's a little different from your competition. Now, monopolistically competitive firms can make positive profits. Their profit maximization condition is actually just like monopolies. They don't have like price equals marginal cost. They have marginal revenue equals marginal cost. Why? Because they face a negative demand curve as a firm. Their demand is not perfectly elastic. Because if you don't have a homogeneous product, you're a little uncompetitive. You're a little monopolistic. The difference is, in the case of monopoly, demand is like a little steeper. In the case of monopolistic competition, demand is not horizontal, but it's not very steep either. It is like elastic, relatively elastic, but not perfectly elastic. So monopolistically competitive firms can make positive profit in the short run. Since kind of there is free entry and exit, almost free entry and exit, in the long run, they make zero profits. Restaurants cannot make positive profits, positive economic profits in the long run. I wish restaurant owners knew that. Sometimes you work very hard, not too much gain, sadly. See, that was the point I was illustrating. In the long run equilibrium, price is touching average total cost, not at the minimum, because it's not horizontal. The demand is not horizontal, it's negatively sloped. It can only touch it like in this section. If your price is equal to your average total cost, your total revenue and total cost are the same. So what is your profit? Zero. In the long run, monopolistic competitive firms cannot make positive profits because it's relatively easy to enter and exit the restaurant industry. It's not as easy as the farmers market, but it's still easy. Okay. It's relatively easy to raise the capital. It's not like you have to come up with like $10 million or $100 million. 10 is even easy, like, you know, but like coming up with like big money is hard. Like when I say big money, I'm talking like hundreds, if not billions. Okay. So long run monopolistic competition. Yep. Price is greater than marginal cost. Why? Because the demand curve is negatively sloped. But price is still equal to average total cost in the long run, meaning zero profit. Now, comparative advertising, I don't agree with that. I mean, you know, yeah, like, you know, if holding a sign, right, like next to the road is like advertising, that's how much they advertise. But how often do you see mom and pop restaurants on when you're watching like cable TV or something, like, you know, it's like, it's not the case. They might have like a local, like in a local paper an ad, but I mean, the only advertising they do is within like I don't know, 100 yards of their own restaurant. Okay, most advertising. Okay, that's it. We finished the chapter. Any questions? Okay, so you all have a good week. You know, all the stuff is available on Connect. I'll make sure that everything is there. The PowerPoints are there, you know, and I'll see you next Monday. Any questions? This week, it is going to be 6 and 7. No, 7 and 8. We skipped 6. 7 and 8. Thank you for asking that. What we covered tonight, 7 and 8. Okay? You all have a good week.